Good morning, dear students. My name is Ferhan Mazher, and today is 10th of April 2021. And right now I am with you, and we are going to study the subject of physics. We are studying O levels physics. The code of the subject is Physics 5054. Today we will be solving it's May June 2022 one paper. It's a theory paper, and this belongs from the zone 1, or you say variant 1. In this session we will be solving the section B of this paper. The section A of this paper I will solve in another video in another session, and I will upload in my YouTube channel. You will be able to find both. I will do it later, but in few days you will be able to find the section A of this paper also. So let's start today's work, and the first question. So yeah. So we are going to solve this paper. So let's go to the next question. We are going to the section B. Okay, so on your screen, the section B is showing. Figure 8.1 shows a lamp from a car. It contains two metal filaments. So here we have that lamp, and it has two filament lamps. Complete the box to describe the transfer of energy that takes place when the lamp is switched on. So the lamps, they have electric energy in them, and that electric energy is converted into light energy and heat energy. So in the first blank, you will write electric energy that will be converted into light energy and heat energy. The efficiency of the metal filament is less than 10%. State what is meant by efficiency. Efficiency means the useful output energy divided by total input energy. Or in other words, you can say is the ratio of the useful output energy to the total input energy. When I say the metal filament is less than 10% efficient, he actually asks you the definition of efficiency, but I'm just describing you. When I say it is less than 10% efficient, it means less than 10%, less than 10% useful output energy we gain. More than 90% energy is wasted. It's a 2-mark question. The first question was of 3 marks. And let me show you my work. I've done this on a paper. Let's see what do we have here. So we increase this. Okay. So here we have electric energy will be converted into light energy and heat energy. So I have, first of all, the actual definition of the efficiency, just that formula. But useful output energy is less than 10% of the total input energy, or more than 90% of the output energy is actually wasted. Efficiency is actual definition of efficiency is useful output energy divided by the total input energy. So hopefully you understand this. Okay, so let's go to the next question. Here we go. Two filaments are usually connected in parallel to a car battery. The student investigates what happens when the filaments are connected in series rather than in parallel. He uses the same battery for the investigation. So they are normally connected in parallel to each other, but if you connect them in series with each other like this, and normally they are connected in parallel, but you connected them in series with each other. So state whether the current, the voltage across each filament, and the total power produced increases, decreases, or stays the same when the two filaments are connected in series. So I've done, it's a very simple 2-mark question, but to understand that actually how we decided, that's a bit difficult. Let me show you my work. So normally you see in the first diagram here, normally the lamps are connected in parallel to each other, and suppose they are identical. Suppose both the filaments, they are identical to each other. So let's say the EMF of the battery is V and the current I will be coming. The voltage drop here will be equal to the EMF of the battery. The voltage drop here will be equal to the EMF of the battery. The reason is when you connect the resistors or lamps or fans parallel to the battery, they will have EMF equals to, they will have the voltage drop equals to the EMF of the battery. So now he says that I have connected them in series. So when you connect them in series, so what happens? The total resistance will increase. The total resistance will become larger. So suppose if both the filaments were identical, then you see what happens. Their resistance will now become 2R. Here the resistance is R by here the resistance is R by 2. Here the resistance is R by 2. Here the resistance of total resistance, because you connected them in series, that will become 2R. So the current coming from the battery, that will reduce. And that will become like the whatever the current before in the parallel circuit was coming out. Here, the current coming out will be 1/4 of that current, because the resistance has increased. In simple word, you can say the current coming from the battery will decrease because the resistance of the circuit that has increased. Now voltage drop, because you see their resistances, individual resistances here are same. So the current coming from the battery is lower, like 1/4 of the previous current. So the current going from here, that will be 1/4 of the current which was flowing here. So whatever the current is here, that is 1/4. So the voltage drop here will also, because you know now the current is coming, that is the lower. So resistance still is same of the L1. So the voltage drop here will be also less. And R2, the resistance is still the same, but the current flowing through it has dropped. So it will have less voltage drop. So the voltage drop will decrease. The current will decrease. The voltage drop will decrease on individual filaments. Another very important thing is what is the total energy. You remember the total energy, the total power. Sorry, the power is equals to IV. So here the current coming from the battery was I, and the voltage of the battery was V. So the power was IV. Here the total voltage of the battery is V, but the current coming from the battery is I by 4. So it will become I by 4V. So you see the P2. So in this situation, the total power will be less. So the current will decrease, the voltage will decrease, the power will decrease. So when you connect the two filaments, for example, in the first case, they were connected in parallel to each other, and then you connected them in series with each other. So when you connected the lamps or filaments in series with each other, the current coming from the battery will decrease. The voltage drop across each resistor will decrease. Each filament will decrease. And the total power produced, that will also be decreased. So the answer is very simple: decrease, decrease, decrease. So let's check let's move to the next part. Okay. So let's check the marking scheme as well. It's very important to always, I have already checked the marking scheme, but you see, whenever you do your work, check it with the marks. So we are on the question number 8. Let me go to the question number 8. Sorry, I'm not it. Okay. So on your screen, the question number 8 is showing. Okay. So 8A first part, electric in the first box, heat, light. 8A second part, energy output divided by energy input. but the actual word which you have to say is useful output energy. It's a must. You should say useful output energy divided by the total input energy. Okay. So then what happens? The next question is 2 decrease. All the 3 decreases, you will get full marks. The current will decrease, the voltage will decrease, the power will decrease. Okay, let's move to the next. Okay. Here we have part number C, figure 8.2 shows the current voltage graph for the 2 filaments. And here's that. So try to understand this. This is a graph, and on the y-axis we have current, and on the x-axis we have voltage. And both is one of the lower one. Suppose this is representing the filament number 1. The upper graph is representing the filament number 2. So they are representing the filament 1 and filament 2. So I can tell for the filament number 1 and filament number 2, for both of them, from this graph, I can tell you that on a certain voltage, how much was the current flowing. So this graph is for this purpose. For example, if the voltage is 12, so the current in the first filament will be 0.5. And when the voltage drop across the filament number 2 is 12, the current flowing through that will be 2 ampere. So this is how you use this graph. So let's move to the question. He says, calculate the total resistance of the 2 filaments when they are connected in parallel to a voltage of 12 volt. So one thing to understand is when you connect the 2 filaments parallel to a battery and parallel to each other, each lamp will have a voltage drop equals to the voltage of the battery or EMF of the battery. So the voltage drop on filament number 1 will be 12 volt, and the voltage drop on the filament number 2 will be also 12 volt. So from using this diagram, I can tell one thing, that when the filament number 1 voltage drop is 12, the current will be 5. And on the filament number 2, when the voltage is 12, the current flowing through it will be 2 ampere. So I've done this, and we want to find, they're connected in parallel, and we want to find out their total resistors. So let's move to the next part. And here you see, I will try to show you how we do this calculation. So here I have drawn that circuit. So we have battery, parallel to the battery, we have connected 2 filaments, 2 lamps, you can say, because they are connected parallel to each other and parallel to a battery. So they have this lamp will have a voltage drop equals to 12 volt, and this will also have a voltage drop equals to the voltage of the battery, that is 12 volt. The current flowing through this lamp we just found by that graph, and that was 0.5 ampere, and current flowing through this lamp 2 or filament 2, the current flowing through it is 2 ampere. We found it from that graph. So if I know the voltage and the current flowing through this lamp, I can find its resistance. R is equals to V divided by I. So I did this calculation here, and you can see I got 24 ohm. So the filament number 1, its resistance will be 24 ohm. For the filament number 2, I know that the voltage is 12 volt. Voltage drop across this filament is 12 volt, and the current flowing through it is 2 ampere. So 12 divided by 2, and it will be 6 ohm. So the resistance R1 is 24 ohm, and the resistance R2 is 6 ohm. And because they are connected in parallel to each other, and we want to find out their equivalent resistance, so what I will do, we will find the equivalent resistance. 1 by R equivalent is equals to 1 by R1 plus 1 by R2. So on your calculator, simply add 1 divided 24 plus 1 divided 6 equals to, and 1 R equivalent will be 5 by 24 if you get the answer in fraction, sorry. And then cross multiply and get the value of R equivalent. That will be 4.8 ohm. 4.8 ohm will be the final answer. The next question, which before going to the question, let me show you the question. The next question is, he asked this question. The two filaments are made from the same type of metal and have the same length. When uncoiled, they both operate at the same temperature. Suggest why one filament has a resistance that is greater than that of the other filament. You see, both the filaments, the length of the wire is same for both the filaments, and both have the same temperature. Then his question is why one of them has the 24 ohm resistance and the other one has just 6 ohm resistance. The reason might be because their material is same, their length is same, their temperature is same, but they have different resistance. The reason can then be their cross-sectional area. The first one, its resistance is 24 ohm, and the second one, its resistance is 6 ohm. So it means the 24 ohm resistor, its cross-sectional area is smaller as compared to the other one. Or you can say the second one, whose resistance is 6 ohm, its cross-sectional area is larger. That's why it has less resistance. So let's check the marking scheme. I have written this answer. Let me show you. Here I have written the answer. Cross-sectional area of the first resistor is smaller. That's why it has higher resistance. Okay, let's check the marking scheme. What the marking scheme says. Let's check out the marking scheme. So he says the final answer should be 4.8 ohm, and that is the answer we got. And then this is the question: smaller area, diameter, radius. So very easy, smaller area. Okay. Now let's move to the next part, and the next part is this one. See, let me reduce the size so you can see the whole thing. Figure 8.3 shows the relay used to switch on a car headlamp. Okay, so it's here we have a relay, here we have that coil. This is the switch which will allow the current to come into the relay. Okay, so explain why the headlamp H lights up when the switch S is closed. Okay, so when you will close this switch S, you see what will happen. The current will start flowing in this coil. And this coil also has an iron core in it. So when the current will flow through this coil will become an electromagnet. When this will become an electromagnet, so it will attract this horizontal portion of the iron armature. So this horizontal portion of the iron armature will go downward. Here it is pivoted. So this vertical portion of the iron armature will move towards left. When it will move towards left, it will push this flexible contact towards left. So both these flexible contacts will touch each other. So when they will touch each other, the path of the current for this lamp H will be completed and this lamp will light up. It is a 4-mark question. It says explain why the headlamp H lights up when the switch S is closed. I have written this answer. Let me show you my answer, and then we will also check the markings. So here we go. He says that when switch S is closed, current flows through coil. Coil becomes electromagnet. Upper end of the electromagnet attracts horizontal portion of iron armature downward. Vertical portion of the iron armature moves towards left. This moves flexible contact towards left flexible contact. They touch the flexible contacts, they touch each other. Path of the current from the lamp H is completed. Lamp lights up. So this is how we will answer, and then let's go to the next part. Let's check the marking scheme as well. You see what the marking scheme says. Marking scheme says that, okay, here we have that marking scheme. Current in the coil or core becomes magnetized. 1 mark for telling that the current in the coil, 1 mark for telling that the coil will become magnetized, and 1 mark is for telling that the attracts iron armature, and 1 mark for telling that the armature turns and contacts closes. So this is how that lamp will switch on. I hope you will be able to write this answer. And let's go to the next part. Okay, the next question is, let me increase the size clearly. So here we have. So the next question is, define what is meant by ultrasound. You see, ultrasounds are longitudinal waves. They are sound waves. They are longitudinal waves, but their frequency is more than 20,000 hertz. So they are out of the frequency range of the audible for the human. So they are inaudible for the human, cannot hear them. So ultrasounds are longitudinal waves whose frequency is more than 20,000 hertz and they cannot be heard by human. So I have written this answer also. Let me show you my answer. So here we go. So you can say that, okay. Sound waves whose frequency is higher than 20,000 hertz are called ultrasounds. They cannot be heard by human, or you can say they are inaudible to human. So 2 mark question. Hopefully you can do this. Okay, move to the next part. Describe what happens to the ultrasound waves as they meet the boundary between 2 different materials. So you see, when the sound wave is, ultrasound is traveling in one medium and it comes across another medium. So from the boundary of the 2 mediums, some ultrasounds will be reflected back into the first medium, and some will be continue traveling in the second medium. Or you can say some will be absorbed by the second medium. So some of them will be reflected back and some of them will continue traveling into the second material. So this is what happens when the ultrasounds come across the boundary of 2 materials. Some will be reflected and some will continue moving in the second medium. I've written this answer. Let me check the marking scheme also. Some ultrasound waves are reflected and some are absorbed by the second material. Very simple answer. Okay. So let's check the marking scheme, what the marking scheme says. Okay. You see the marking scheme is showing on your screen. Question number 9, and its first part is sound that cannot be heard, and sound with the frequency about 20,000, 20k hertz. And 9A, second part, some sound is reflected, some ultrasound is reflected, and some pass into new material or some absorbed by them. So hopefully you can write these answers, and let's move to the next part. Okay. So look at these questions carefully. He says, to produce the image of an unborn child, an ultrasound emitter and receiver are placed close together so on the mother's skin. Figure 9.1 shows pulse detected by the receiver. So understand this, what is this? So you send the ultrasound at 0.02 second and the reflected sound, ultrasound was received at 0.05 second. So how much time it took for the ultrasound to go and come back? 0.05 minus 0.02, it will be 0.03 second. It's millisecond, sorry. The unit is millisecond. So you send ultrasound at a pulse of ultrasound at 0.02 millisecond, and its echo or its reflected ultrasound was received at 0.05 millisecond. So how much time it took for the ultrasound to go and come back to the detector. It took 0.03 millisecond. And you know, millisecond means 1/1000 of a second. 1/1000 of a second. 1 divided by 1000. So if you want to convert this into seconds, you have to divide it with 1000. So hopefully you understand this. And let's move to the next part. He says pulse A is emitted pulse, and pulse B is the first pulse that returns from the unborn child. The average speed of the ultrasound in the human tissue is 1500 meters per second. Calculate the distance between the emitter and the child. You see, now I know the speed of the ultrasound in the tissue. And I know the time taken for the ultrasound to go and come back. So simply multiply the speed with the time. So you can multiply 1500 meters per second with 0.03 divided by 1000, and you will get the distance traveled by the sound in going and coming back. Now we want the distance between the emitter and the child, so I will divide that distance at the end with 2, because I just want the distance between the emitter and the child. So by doing this, I will be able to find out the distance between the emitter and the child. I've done this on a paper. Let me show you my work on your screen. It is showing question number 9A, third part. I think you can see that that's done in the blue third part. So T, when you send, when the time taken for the ultrasound to come back is 0.03 millisecond. So the distance is equal to speed multiplied time. Here you can see speed multiplied time. So it will be 1500 meters per second multiplied 0.03 divided by 1000. So it will be 0.45 divided by 10. I'm just doing the calculation. So the final answer will be 0.045 meter. So if you convert it into centimeter, it will be like 4.5 centimeter. But I told you that distance is going and coming back. So divided with 2, you will get the distance between the emitter and the child. So 4.5 centimeter divided by 2, and it will be 2.25 centimeter. Or in other words, you can see you round it off, this will be 2.3 centimeter. So this is that numerical. So I hope you will be able to do this numerical. So that's it. And let's check what is the marking scheme saying. Marking scheme says that it will be 0.023 meter. So I think that our answers are right. We wrote the answer in centimeters. So there we are good. Okay, so let's move. Let's move to the next part. He says the speed of the ultrasound in human tissue is close to the speed of the sound in the water, suggests approximate values for the speed of sound in gas and in solid. Speed of sound in gas, like in the air, is 330 meters per second. Just a number, you just have to suggest a number. 330 meters per second is the speed of the sound in the air, and speed of the sound in the solids. It, for example, it might be it is like 5000 meters per second in iron. In iron, the speed is 5000 meters per second. So you can just write those numbers. Let me check you the marking scheme. Let me check the marking scheme, what answers I can write here. So you can write here 150 to 1000 meters per second. I said in gas it's 330. And in solids, like it's 2000 to 8000 meters. I remember the speed of the sound in the iron is 5000 meters per second. So you can write any number from 2000 to 8000 meters per second. Okay, so let's move to the next part. He says, here we go. Figure 9.2 shows an X-ray image of a hand. An X-ray detector is placed just below the hand. An image of the bones and human tissue around the bone is formed on a screen by the detector. Describe what happens to the describe what happens to the X-rays to produce the image. It's a 3-mark question. You see, X-rays, they are able to pass through the tissue. X-rays can penetrate or pass through the tissue and reach the detector. X-rays cannot pass through the bones. The reason is the bones are very dense. So the X-rays are unable to penetrate through them. So through the bones, the X-rays cannot pass. So wherever you will have the bone, the X-rays will not reach the detector. When X-rays reach the detector or the photographic film, wherever the X-rays will fall on the photographic film or the detector, that portion will become dark. And where the X-rays will not reach, that portion will become white. That will remain white. Okay. So through the flesh and through the organs and through the tissues, the X-rays will pass so that their image will be a little dark. But through the bones, because the X-rays cannot pass, so their image, the image of the bones will be white. So you can see wherever we have white, that means bone, and wherever we have dark portion, that means they are tissue or flesh. So I have written this answer also. It's a 3-mark question. And let me show you my answer. Make this correction. This is 5,000 meter per second. This number, speed in solids, it is 5,000. 1,500 is the speed of the sound in the water. Kindly make this correction. So, let me correct it here. Okay, so let me take it to the paint and I will paste it here. So let me take the rubber. And put a 0. Yeah. To draw a 0 with the mouse is quite difficult. Or let me. So it will be a second. So the speed of the ultrasound, the speed of the ultrasound is 5,000 meter per second in the sounds. It's the speed of the sound in the railway tracks in the iron. Okay, now action question we are doing is question number 9B, first part. Most of the X-rays can pass through the tissues and reach the detector. Tissue appears to be dark on screen. X-rays cannot pass through the bones because they are very dense. So bones appear lighter in color on the screen. X-rays cannot reach detector where bones are present. So this is how the image is formed on the X-ray. This is how the X-rays are used. Let me show you the marking scheme as well. So the marking scheme says that, so let's see. Let's check the marking scheme. Okay, it says X-rays make the image blacker when the X-rays reach the detector. That portion where the X-rays are actually able to reach the detector, that portion will become darker. X-rays absorbed by the bone do not reach detector through bone. Some X-rays pass through the tissue or tissue absorbs some of the X-rays. So this is how you have to write this answer. I think our answer is perfect. So let's move to, that was a 3-mark question. Okay, the next question. So the next question on your screen is the wavelength of X-rays used is 2 × -9 meter. The speed of the electromagnetic wave is 3 × 8 meter per second. Calculate the frequency of the X-rays. The frequency of the X-rays, you know, famous formula, V is equals to F lambda. And if you want to find out the value of the F, it will be V divided by lambda. F equals to V divided by lambda. Just put these values and do the calculation, and it will be very easy. I've done this for you. And you can see question number 9B, second part, that's showing on your screen. Yeah. V equals to F lambda and F is equals to V by lambda. So it will be 3 × 8 divided by 2 × -9, and the final answer will be 1.5 × 17 hertz. So on your calculator, you will see, write 3 × 8 divide 2 × -9 equals to, and you will get directly this answer. Very easy numerical. Let's check its answer. We have answer in the marking scheme. So let's check. So 1.5 × 17 hertz. And so our answer is right. The X-rays causes mutation, cancer, kill cells, energy. That's the next part. Suggest one reason why X-rays are not used to form an image of an unborn child. You see the X-rays, they have very high energy. Their frequency is higher, and they can damage the tissues. They can cause the mutation of the cells, and that's why we don't use this for imaging unborn children. For imaging unborn children, we use ultrasound because they can cause mutation of the cells. So I have written this answer. I hopefully this answer is visible to you. X-ray have high frequency and they have energy. They have higher energy, so they can cause mutation of the cells. That's why we don't use them to image unborn children. Okay. So the next part. Okay, next is question number 10. And it says question number 10 is here. So figure 10.1 shows a motor lifting a mass. Figure 10.2 shows part of the circuit diagram of the connections to the motor. So here we have a motor here, and when it will work, it can lift this mass upward. Here is that diagram, the circuit which we used. Here we have a battery, we have a switch, here we have a motor. So what they want? He says that the question is that the current in the motor is 1.5 ampere and the voltage supplied by the battery is 8.0 volt. Complete the circuit diagram in the figure 10.2 to show an ammeter and a voltmeter in the correct positions to take these measurements while the motor is working. So in this diagram 10.2, we have to put ammeter and we also have to put a voltmeter here. So ammeter is always connected in series with the motor and the voltmeter is always connected in parallel to the motor. I've done this diagram. Let me show you the diagram I have done. So here we go. So you can see here that is the first part, and here we have connected an ammeter. Ammeter is connected in series, and here I have connected a voltmeter, and the voltmeter is connected in parallel to the motor. So let's move to the next part. That was 2-mark question. The motor takes 4 seconds to lift the mass. Calculate the electric energy transfer to the motor in this time. You know the data. We know the current, we know the voltage, we know the time, and we want to find out the electric energy. The method is very, very simple. You see, the method is simple. Energy is equals to IVT. Energy is equals to IVT. So IVT, I can, let me show you. So here you see, we have that part done. So this is question number 10A, first part, energy is equal to IVT. So I will be 1.5 ampere, V is 8, and time is 4 seconds. Just multiply them. You will get the answer 48 joules. The answer will be 48 joules. And then we have the next part. In the next part, he says the motor lifts the 150-gram mass through a height of 80 centimeter in 4 seconds. Calculate the gravitational potential energy gained by the mass. The gravitational field strength G is equal to 10 Newton per kg. So you know that the gravitational potential energy very easy, mgh. But the only problem is the m value should be in kg, and the g value is 10 Newton per kg, and the height value, h value should be in meter. So I can convert 150 gram divided with 1000, it will become 0.15 kg, 0.15 kg, I think. And 80 centimeter divided with 100, and it will be converted into meter. So it will be 0.80 meter. So simply put those values in the MGH formula and you will get the answer. Let me show you my work. I've done this numerical also. So here, potential energy is equal to MGH. So 150 divided by 1000 to convert it into kg, multiply 10, multiply 0.8, and the final answer will be 1.2 joules. 1.2 joules. Okay. So let's check the marking scheme for these two numericals, because this is our theory and that this is our philosophy, that whenever you do a question, you should check the marks. So ammeter in series connected switch with the motor, voltmeter across motor or battery. E is equals to VIT, and the final answer will be 48 joules. Our answer is also 48 joules. And potential energy is mgh in any form of numerical algebraic. And then you put the values, and 1.2 joules will be the final answer. So hopefully you have understood this. And then the next question, we move to the next part, and the next part is state two reasons why the gravitational potential energy gained by the mass is less than the electric energy supplied by the motor. So the electric energy which is supplied to the motor, by the motor, I said to the motor, that electric energy also is converted into other forms of energy that which are wastage of energy. For example, now you see the that motor has to lift the weight of the rope also. So that's the wastage, because we have not calculated it in the gravitational potential energy. So one reason might be that the motor has to lift the weight of the rope also. Another thing can be that some of the electric energy was converted into, because the body is moving upward, so it has kinetic energy. So your electric energy went into kinetic energy. And we are not calculating it, and we are not considering it. So some of the energy has been converted into the kinetic energy of that mass, which is moving upward. And another reason can be because when you move upward, you have to overcome the air resistance. So some of the energy went into overcoming or doing work against the air resistance. Another reason can be because the motor, it has wiring in it, and that wiring, those wires has resistance. And when current flows through them, the current, the electric energy is converted into heat energy, which is a wastage of energy. So there are many reasons. So you just have to write here too. I have written this answer. Let me show you my answer, and then we'll check the marking scheme. Some energy is converted into the kinetic energy of the mass. Heat generated in the motor wire due to resistance of the wires. This is my answer. Let's check the marking scheme. What the marking scheme says. Marking scheme says that motor mass has motor and mass both have kinetic energy. That can be the one reason. Heat generated in the motor wires, heat generated in the air due to the drag or the air resistance, or work done to lift the string. You also have to lift the string. the rope with which the mass was attached. So let's go to the next part. Okay. Figure 10.3 shows the structure of motor. When the mass reaches the top of its motion, the switch is opened. This disconnects the battery and causes the mass to fall. The coil turns as the mass falls. As the coil turns, a small voltage is produced. Explain why a voltage is produced as the coil turns. You see, the coil is like this, and the coil is in the magnetic field. The magnetic field is from north to south. We have permanent magnets there. Their magnetic field is from north to south, and the coil is in that magnetic field. So when the coil will turn, it will cut the magnetic lines. When coil will rotate or it will turn, it will cut through the magnetic lines. And when a coil cuts the magnetic lines, EMF is induced in it. And that is called electromagnetic induction. So EMF, that's why the EMF is induced. And let me show, it's a 3-mark question. He says, explain why a voltage is produced as the coil turns. It's a 3-mark question. I have written this answer, then we will see the markings. So here we go. Let me show you my answer, and then we will go check the marking scheme. Coil cuts through the magnetic flux. Due to changing number of magnetic lines of force, EMF is induced in the coil. This is called electromagnetic induction. You see, the coil is turning, so it is cutting the magnetic lines. When the coil will cut the magnetic lines, automatically EMF will be induced. We call it electromagnetic induction. Let's check the marking scheme. The marking scheme says that, what should we say? It says 3 mark. 1 mark. 1 mark is for saying that the mention of the magnetic field between north and the south. 1 mark is for telling that there is magnetic field present from north to south. And the 1 mark is for saying that the coil cuts lines of magnetic. When the coil will turn, it will cut the magnetic lines or magnetic lines or flux or field in the coil changes. And 1 mark is for telling that this is electromagnetic induction. Induction means that the EMF will be induced in the coil. It's a 3-mark question, a very, very famous question. You should remember this answer. This answer comes so many times in the paper. Kind of remember this. Okay, so let's move to the next part. He says the mass. Okay, as the mass falls, a student connects a wire between the point A and the B shown in the figure 8.3. He notices that the mass takes a longer time to fall when the wire is connected. The student suggests that this is an example of Lenz's law. State Lenz law that suggests why the mass takes longer to fall. You see what he's saying. He connects A and B with each other with a wire. And then what he do? He let that mass fall. You see this mass fall. He's talking about this. When this mass will fall, there's no electricity, basically, but when it will fall, the armature of that motor will rotate, because when this mass will go down, the armature on which we have the coil, because this mass is through the string connected through that armature, and when this mass will go down, this armature will rotate, that coil will rotate, and when that coil will rotate, automatically EMF will be induced in it. And according to the Lenz's law, according to Lenz's law, the EMF which will be produced, that will be such a way that the direction of that EMF will be such that it will try to oppose the cause which is producing that EMF. Try to understand. The Lenz law says when this mass will go down, it will make that armature of that motor to rotate, and due to this, what will happen? The current will be induced in that coil, and the direction of that current will be in such a way that it will oppose the cause which is producing it. So it will oppose this motion. This mass is going downward. So how it will oppose? The trick is very simple. You see, when this coil will rotate and current will be induced in it, so what will happen? It will have its own magnetic poles, north and south. And though it whatever will be its north, it will be attracted to this south, and whatever will be the south of this coil, that will be attracted to this north. So they will, because of the attraction between this electromagnet and these poles, what will happen? Its speed will slow down. It will slow down the mass which is going down, because the electromagnet which is formed on that coil and the permanent magnets, their opposite poles will be attracting each other, so they will slow down the falling body. The current induced in the coil is in such a way that it will try to oppose the cause which is producing it. The mass is going downward, it is producing that current, that EMF in the coil, and direction of that EMF will oppose this, the mass falling down, so it will slow down. And how this happens? Because of the magnetic poles which are formed on the coil. So obviously there will be two poles, north and south. The north of the coil electromagnet, the north formed by that electromagnet will be attracted with the south of the permanent magnet, and they will slow down it. Okay, so I have written, try to write this. It's very difficult to write this answer. You see, it's little, the wording is difficult to. Maybe you are able to understand the concept which I am trying to tell you. Its wording is quite difficult to answer. So current induced in the coil opposes the change producing it. This is the definition of the statement of the Lenz law. Coil will become a magnet. Poles of coil, the electromagnet which is formed on the coil, the poles of the coil will be attracted to the opposite poles of the magnet. So that's why it will slow down the movement of the coil. So the mass going down will also become slow. So it will take a longer time to mass to fall if it is attached with the motor. The motor will be acting like a generator. So let's check the marking scheme and then done with this paper. Okay, so see on your screen. This is showing on your screen. And if I increase the size, it is the most difficult answer to write. Okay, so this is how we write. Statement of the Lenz's law: induced current, the current which is produced in the coil, flows in a direction to oppose the change producing it. So whatever is the cause producing it, the current induced will have a direction in such a way that it will oppose that change. Coil becomes a magnet, or current flowing in the coil produces force in the field. Poles of the coil attracted to the opposite poles on the magnet, or force up on a side as side moves down. So you can have a good look on this marking scheme here, and I hope that you can write even better answers. The answers which I wrote, they are just answers. They are just an example that how you should write your answer. You can write, my students write better answers than me. You see, have a look at the marking scheme and look at my answer, and then make your own. So that's it, G. So we were today, we were doing, so today we were doing question number. So my dear students, today we were doing May-June 2020 Physics 505421 paper. It's a theory paper, we call it paper 2, and this paper belongs from the zone 1. And you know this, on my YouTube channel, I'm only working on the theory papers. And which theory papers I'm working on? The theory papers which belongs from the zone 1. The papers of zone 2 you can find in the yearly red spot, and I think you can solve it from there. But the zone 1 is not available in the red spot, so I am working on the theory papers of the zone 1. So in this video, we have worked on the section B of this paper. Section A of this paper, we will be working in another video. I will make it in few days and upload it in my YouTube channel. So keep watching my YouTube channel, because when you watch my YouTube channel, it supports me, it gives me energy. So if this video is helpful to you and this is making a good impact in your life, and it's making your life little easier in the regard of physics concepts and preparation for the CAIE, kindly subscribe to my YouTube channel, and also suggest these videos to your friends, because by sitting at home at your own home, you can practice the theory paper of the physics on the zone 1, and you can excel in that, and you can get good grades, and you can have good knowledge also. So thank you very much, everybody, and have a good day, and God bless you all.